Hi, this is Barrett Givens, and in this video, we're going to talk about some facts about the boundary of a set. Okay, suppose you have a subset of a topological space. We're going to call this set A, and then I'm going to just give you a bunch of different facts about the boundary. So the first one is that the boundary is a closed set. Well, why would that be true? Why would the boundary be a closed set? Well, the boundary of A is the closure of A minus the interior of A. And the meaning of doing minus a set is that it's really the same thing as intersecting with the complement of the set. So this shows that the boundary of A is a closed set minus an open set, which is the same as a closed set intersected with a closed set. The intersection of two closed sets is closed, so the boundary of A is closed. Okay. The next statement is that the boundary of A is equal to the closure of A intersected with the closure of A complement. So why is that? Well, the boundary of A is the closure of A minus the intersection of A, which is the closure of A intersect the interior of A complement. But we have a theorem about what the interior of A complement is. That's the closure of A intersect the closure of A complement. That's a theorem that we have about closures and interiors and complements. All right, so that statement is true. Now the boundary of A and the interior of A are disjoint. The boundary of A and the interior of A are disjoint. Well, that's sort of clear. If X is in the boundary of A, that means that X is not in the interior of A by the definition of boundary. It's the closure minus the interior. So you've taken all the interior points out. Okay. Next, we have the statement that the boundary union the interior is equal to the closure. Well, again, the interior is a subset of the closure. So this is because, let me get my pen here. This is because the interior of A is a subset of the closure of A. And the boundary is what you get when you just take the interior points away. So if you add the interior points back in, you get the closure. Next, a set A is closed if and only if it contains its boundary. And it's open if and only if it's disjoint from its boundary. So a set is closed if and only if it contains its boundary. And it's open if and only if it's disjoint, so it contains no boundary points. It's closed if it contains all boundary points, and it's open if it contains no boundary points. So why would that be? Well, if A is closed, then A is equal to the closure of A. And the boundary of A is always a subset of the closure of A because it's the closure of A take away something. So the boundary of A would be a subset of A in that case. And then if A is open, then A is equal to its own interior. And we already know from above that the boundary of A and the interior of A are disjoint. And so that would mean that the boundary of A and A are disjoint. Okay, I sort of just explained those both as if they were if-then statements, but these are if and only if statements. So I'll leave the other direction for you guys to figure out. All right. If A is both closed and open, then the boundary of A is the empty set. We can figure this out by looking at part 5. If A is closed, then the boundary of A is a subset of A. And if A is open, then the boundary of A is disjoint from A. How can that happen? How can you have this thing, the boundary, which is both disjoint from A, but also a subset of A? The only way that can happen is if the boundary of A is the empty set. Another way to think about it is that if A is both closed and open, if A is both closed and open, then A is equal to the closure of A, and also A is equal to the interior of A. And so the boundary of A would be A minus A, which would be empty set. Okay. And then finally, the last one, if we write exterior of A to mean the interior of A complement, so like the inside of the outside of A, then every topological space can be written for any set. You can write it as the interior, union the exterior, union the boundary. So your whole space X, here's my set A, okay? The interior is the part that's inside A. The exterior is the part that's outside A. And then the boundary is the edge of A. And this says that basically every space can be split up into these three parts, the inside, the outside, and the wall. Okay? So, and that's true no matter what A is. All right. So those are just some quick and basic facts about the boundary of A. And all of these facts can be useful when you're trying to figure out for a particular space what the boundary is, or if you have a theorem about boundaries, all of these various identities might come in handy. Okay, thank you for listening.